having me. Really happy to be here. I'll fast forward past the introduction because you just did that for me. There's 2 books. I may have brought the book stickers with me for the Wolfie book. I don't know if y'all have seen the book stickers that I have, but for that one, there's a unicorn sticker that dresses up the Palomino horse as a unicorn, and for the Wolfie, there's a little sticker pack that makes him look like Hello Kitty. So if you like stickers, I've got stickers. All right, I'll move this along. Every technology is now a tech company, which means, this means a lot of things, but the most important and interesting thing it means to me is that things like engineering efficiency and team performance and how well we collaborate, how quickly we do our work are no longer just niche concerns. They actually matter to a lot of people. And it has never been more true that it really pays to be on a high-performing team. Now, the way I define high-performing team is maybe a little different than most, but I define high-performing teams as teams that get to spend most of their time solving interesting, novel problems that move the business materially forward. There are lots of statistics that, obviously pull review counts and lines of code and everything that we use to evaluate our work, but for me, the one that, best sort of gets at the cross of the humans and the output is this. And if you read the DORA report, you're probably familiar with some of these alarming statistics. But this also matters to me because the team is the smallest unit of software ownership. Individuals don't own software. Teams do, for the same reason that a server can't run your application code. You need pods, you need resiliency, you need redundancy, you need shared resources. So how do we build high-performing teams? Obviously, we hire all of the ex-FAG engineers we can get. No, of course not. Of course not. Engineering excellence is not unrelated to team excellence, but they're maybe less related than people might think, and sometimes they are related in directions that people might think. Because how well your team performs is not the same as how good are you at engineering. In fact, your ability to ship code safely and swiftly has a lot less to do with your knowledge of data structures and algorithms, which are important prerequisites, and a lot more to do with the socio-technical systems that we live in, which is why I believe that if technical leaders have one job, it's this. It's paying attention to the feedback loops. And when I say technical leaders, I don't just mean managers and directors. That's everybody who, senior software engineer has a lot of meanings. To me, it just means more like you're an actual engineer. Like I think it takes a good 7+ years to become a good engineer. And at that point, you're a technical leader, right? It's your job to create value for the company, but it's also your job to co-create the teams and the socio-technical systems that we live in. So when I think of modern software development practices, these are the things that I really think about. Engineers owning their code in production, observability-driven development, which to me means you're writing your code, you're instrumenting it as you go, and then when you deploy it, you go and you look at that instrumentation through, you look at your code through the lens of the instrumentation you just wrote, and you ask yourself, is it doing what I expected it to do, and does anything else look weird, right? And you keep that loop as tight as possible. Testing in production, which you were just talking about, excellent. In fact, if you haven't seen my shirt, it says, test in prod or live a lie. I also have stickers of these. Separating deploys from releases using feature flags. This is so important because, as we all know, speed is safety when it comes to software. Getting small diffs out constantly. Those needs are real, and they're actually incompatible with the needs of, say, marketing or product, which needs to have predictable, stable release dates. The way that we cross that is by separating the two. And continuous deployment. I'm a big fan of the philosophy that as soon as you deployed your code and merged it, the bot should pick it up from there. The bot should pick it up, roll it out, test it, roll it out, so that as soon as you merge your code, you know it's going into production without any human intervention. But what do all of these have in common? They're all about fast feedback loops. All of them. They feed on each other. This is what feedback loops do, right? They amplify, or they balance, but Most of these amplify. They feed on each other. So the faster you make one thing, the faster you can make another thing. You get your code into production as fast as you can. Because when it comes to software, speed is safety. Like, as human beings, we have this sort of physiological response. When we get afraid, we freeze up. Like, we want to slow down. We want to take stock of our circumstances and see what's going on before we take another step. And we really have to train that out of ourselves when it comes to software, because software is more like ice skating or bicycling, both of which you're very familiar with here. If you slow down, what happens? You fall over. It's the same with software. Getting code into production fast is the key feedback loop that everything else proceeds from. Why? Well, the cost of finding and fixing problems goes up exponentially from the moment that you write them. You type a bug, you backspace, good for you. Can't fix it any faster than that, right? You find it in your tests, great. After that, you find it right after you deployed it, wonderful. If you didn't find it then, it's probably not going to be you that finds it. It's going to be someone else. Maybe a user, maybe another engineer, maybe some combination of the two, next month, next year. Maybe it just sort of settles into the background static and noise of our wobbly production systems as they are, which, by the way, anyone who has green dashboards all the time, it just means your dashboards aren't granular enough, because there is so much broken stuff going on all the time in your systems right now. You probably wouldn't sleep if you knew how much was broken. And that's fine. That's great. Our systems are so complex that many things are failing all the time. And that's why we build in resiliency, right? Your bugs need to get to a certain level of mattering, for lack of a better word, before it's worth putting engineering attention on. And that sort of push and pull is like what our jobs are all about, right? But our ability to do this well is really grounded in the quality of our observability. Observability's had a lot of definitions over the past few years. I am probably responsible for more than my fair share of them. Back in 2016, when Christine and I started Honeycomb, it wasn't really a term that was used in the software industry. We talked about monitoring, but not about observability. And I remember very clearly, like in July of 2016, I was looking around for how to describe what we were building, and I stumbled upon the control theory definition. In control theory, it's how well can you understand the inner state of the system just by looking at its outputs. And I had like one of those cartoon like light bulb moments, just like, oh my God, this is what we're trying to do. And we spent the next couple of years, like we were kind of the only ones talking about it from 2016 to 2018, 19. And we came up with this laundry list. We were like, well, you have observability if high cardinality, and everybody tunes out because nobody likes laundry lists. And then this other definition came along. Observability has 3 pillars: metrics, logs, and traces. And around 2020-ish, the term really started to pick up. Gartner added it to the Magic Quadrant. Recently it's coming for, but like the definition of observability has kind of started to get defined down to the mean, right? It's just a generic synonym now for telemetry, which is why these days, when I talk about observability, I really think about it this way. Observability is a property of complex systems, just like performance or scalability, reliability. I like that this puts the emphasis on the system instead of, the tools. But if we accept this definition, it kind of leaves us with a conundrum, because there's been a huge step function in recent years in value, in usability, in cost model. And, it's something we've experienced. It's something that I know a lot of people experience. And using the same exact words really blurs out a bunch of these differences, which is why I feel like I should apologize in advance, but I feel like it's time to version observability. And if you refer to, semantic the canonical semantic versioning precepts. You should only do a major version bump when it's a backwards breaking incompatible change. And I think that's what we have, because the past 3-4 decades of software were built on this model, 3 pillars. You've got metrics, logs, and traces. And 2.0 is built on a very different model, where you have a single source of truth. You have arbitrarily wide structured logs from which you can derive metrics, you can derive logs, you can derive traces, you can zoom in, you can zoom out, you can do all kinds of things, but you have one source of truth, which dramatically changes a lot of things. So let's start by, it's really kind of amazing to me that such a small difference in how you store the data on disk can have such dramatic, not only technical, but socio-technical ramifications. So Observability 1.0 is very much about, you've got many sources of truth, right? You've got your metrics-backed APM, you've got your RUM, you've got your logs, you've got your traces, you've got your metrics, you've got your dashboards, you've got your analytics, you've got your profiling. All of these different sources of truth, and what connects them? You. You are the only thing that connects them. You are the engineer who's sitting here eyeballing a graph in this dashboard and going, well, it's kind of the same shape as that dashboard. It's probably the same thing. Or I've got this dashboard, I think this is the problem, so I'm going to jump to my logs, eyeball the timestamps. Well, these are probably the same thing. Okay, I've got something from my log that I want. I'm going to copy paste the ID from this log tool over to that tracing tool and hope that we captured it. Nothing connects these sources of truth except you, the engineer. Or in some very, mature products that you can predefine a few defined data points, sort of do a cross data set join. Doesn't work very well. And because there's no connection between these data sources, how do you debug? Well, you do a lot of guessing or informed intuition. You've seen this before, so you can pattern match it. But you're guessing that this graph is the same problem as that graph. You're not actually going, these are the same. You can't. There's no way to do that. And Observability 2.0 is based on the opposite premises, that with these wide structured logs, you should be able to explore and interact and zoom in, zoom out. So I'm going to go into each of these in a lot more detail, but the point I want to make right now is that this whole laundry list of things, nobody was going to remember that. It's too hard, and it's not, there's a lot of wiggle room. But I think this is very easy to remember, and this is very, very meaningful, that if you have 3 pillars and many tools, you have Observability 1.0. If you have a single source of truth, you have Observability 2.0. They're not compatible. You can't have both one and many. So let's look at a few of the differences. I've got to be mindful of time. I know we started late. So I'll go through some of this kind of fast, but I will also post the slides online. How the data gets stored. We already talked about a bunch of these, but I also want to pull attention to the last one. In Observability 1.0, this was a world, these tools were developed in a world where hardware was very expensive, right? Disk was expensive, CPUs were expensive, God, RAM was so expensive. And so you tried to capture as little data as you could. And so you made decisions when you were writing the data. You're well, we're going to strip out all that context and we're going to write this, right? This is how all of you have formed metrics, right? You're okay, I'm going to capture a custom metric for an intersection of, these details. And with Observability 2.0, hardware is no longer expensive. It's incredibly cheap. So we're store the raw data and do aggregation at read time so that you don't have to define in advance, I'm going to need to ask and answer these specific questions. You don't know what questions you're going to have to ask. You don't know what questions you're going to have to answer because you don't know what's going to happen. There are only 3 types of data under the hood. There's the metric, unstructured logs and strings. RUM tools are traditionally built on top of metrics to describe user sessions, APM to describe application. Now, you may have heard me rant about metrics a lot. This is not because there's anything wrong with metrics. Metrics have done a very good job for us for a very long time. They are doing the Lord's work. They're very tiny, right? we use the word metric in two different ways. We use it generically, like the metrics are down, just as a generic synonym for telemetry, right? And then we also use it in a very specific technical sense. The metric is a number that we store in a time series database. The metric can only be a number. It can't be a struct, right? It's a number, you can append some tags. It's very fast and very cheap and very small. And it's the right tool for the job when you're trying to summarize a vast quantity of data. Because you can't ask new questions. You can only ask the questions that you defined in the beginning when you created the metric. Those are the only questions you can ever ask. It's a great tool for summarizing. It's a terrible tool for trying to understand things. You don't get any, like high cardinality, for those of you who are unfamiliar with the term, cardinality refers to the number of unique items in a set. So if you've got a collection of 100 million users, then like any social security number is a unique number per user in the US. That is the highest possible cardinality. Low cardinality would be like, is your gender M or F? Very low cardinality. Metrics tools can only work with low cardinality. It's very expensive when you try to do high cardinality and not really possible. But when it comes to debugging and understanding your data, cardinality is kind of all that matters. Like, it's the only identifying information. It's application IDs and usernames and, password hashes and shopping carts. And like, this stuff is incredibly important to understand. Which is why, to understand our systems, we need to turn to logs. Even unstructured logs are more powerful than metrics because they preserve some context. Pardon my French. This is Europe, so I can swear, right? Thank you. Okay, structure your fucking data. It's 2024. We have no excuses for not structuring our data. However, logs have the issue that they are typically emitted many, many times during a request. So the data you need is scattered throughout many different log lines. And you kind of have to know what you're looking for in order to find it. You know a string that you put in some important breakpoint. You grep through the code for something and you look for it. You have to know what you're looking for in order to find it. And the more logs you collect, the slower it gets. Who uses it and how? So one of the most interesting sort of side effects of this is that I think in Observability 1.0, we really focus a lot on the ops use cases. Is it up? Is it down? MTTR, MTTD, reliability. How are we going to monitor this? And in 2.0, it's more like this is what underpins the entire development lifecycle, right? This is what allows us to move fast. How much, I'm all off time-wise, like how much longer should I go? 15 minutes, thank you. Great, perfect. If you can't see what you're building, you slow down. Observability 1.0 is very much about how you operate software, and 2.0 is about how you develop software, which includes operating it, obviously. But this conversation has traditionally focused on software problems, bugs, outages, performance regressions. And there's so much more to our code than just that, right? Understanding our software is not just about understanding when something goes wrong or when something is bad. We need to understand our software 1,000,000 times a day in order to make wise choices about what to do, in order to understand what our users are doing, and in order to understand, whether what we did has worked. And you can't do that with just high-level aggregates. You have to be able to use a scalpel. The BI folks, the business intelligence folks, figured this out years ago, right? There are no BI tools that are built on top of metrics. They don't exist. Because on the business side, the connection to value is very clear, and so people are willing to spend a lot of money. So they've been doing that for years. How you interact with production. In the past, there was, dev versus ops. And I feel like the whole DevOps era, like I really hate the people who are like, DevOps is dead. It's not dead. But I do think that we're sort of coming to sort of the natural end of the era in that the dev and ops silos increasingly don't exist. So you don't need to spend a lot of time like breaking down silos and like paying, because in the future, increasingly, every engineer writes code, and every engineer is expected to support the code that they write. This is so much healthier because our systems are becoming so complex. You can't hope to understand the code if you didn't also write it, and you can't hope to write the code if you don't also understand it. Like in retrospect, it kind of doesn't make sense that we ever thought we could split up these disciplines into half of the engineers will write the code, half of the engineers will understand the code. Increasingly, instead of feeling like our jobs are done when we commit code and test pass, like your job isn't done until you've watched it run in production. The way we debug in 1.0 land is very much flipping from dashboard to dashboard. Like, we kind of talked about this, right? And because of this, because it leans so much on intuition and guessing, it follows that the best debugger is always the person who's been there the longest. And like, I'm not gonna lie, I've always been that guy, and I love being that guy. Like, I love being that guy. I love being the debugger of last resort. I love being the person who, when nobody can figure out what's going on, they come to me, and I sort of lean back in my chair, and I survey the like dashboards. I'm like, it's Redis. Like, I know it doesn't say Redis anywhere, but trust me, it's Redis. Like, and they go, and they're like, oh my God, it's Redis. And I'm like, yes, it was Redis. Like, I love that. Who doesn't love being that guy? But it doesn't really scale. As I found out when I got paged in my honeymoon at 3 a.m. and they were like, MongoDB is down. I'm like, oh, I wish I'd taught someone how to do this. It doesn't scale. And in Observability 2.0, you don't have to guess. You follow a trail of breadcrumbs. You ask a question, you look at the result, you ask another question based on that result, and you ask another. It's more like, well, it's more science-y, let's put it that way. You form hypotheses, but the data, the connective tissue of the data is there in the tool, and it's available to everyone. It doesn't rely on these very complex mental models that we've built up over the years. The data is in the tool. You can find the connections, and that means that the best debuggers are the people who are the most curious, the people who make a pattern of looking on their code after they've deployed it. I've seen this happen like 2 or 3 times now at companies that I've worked at where the best debuggers have gone. And I'll tell you, like it was a ego death for me the first time this happened at Facebook when suddenly the juniors were like debugging things faster than I could. And I was like, well, shit, I guess I better get on board. But it's so healthy for us. It's so good for us. I mean, how depressing is it to join a team and know that you can never be the best debugger? It's not good. The cost model here is super interesting. And I wrote a long piece about this somewhat recently, so I'm not going to spend a lot of time on this. But I think that there's been a real sort of cost crunch lately in the post-zero interest rate era where people are starting to pay attention to their observability bills and they're going like this. And there's a reason for that. Because you're paying for so many different tools, you're paying to store your data in so many different formats that don't talk to each other, aren't connected to each other, that your cost goes up. Like if your traffic is going up at a 1x multiple, your observability cost is going up at a 7x, 8x, like however many tools you're paying for, at best. At worst, or at usual, it's going up much faster than that because Meh-trics, all right, I've been doing this for 8.5 years, and I just figured out this year that when the big vendors say custom Meh-trics, they don't actually mean, like, when I hear custom Meh-trics, I think each custom metric is a line of code. Well, that's not what that means. What that means is a custom metric is every unique combination of a metric and a tag value. So I published a little white paper on this recently, and I did some math, and it blew my mind. So I asked Christine to check me. She's like, no, that's right. Finally published it. So the math goes like this. If you have 1,000 hosts, and you're trying to monitor, 63 status codes for 5 handlers and 20 methods, guess how much it costs you per month? $63,000. That's just for a heat map for one metric. Now, anybody who's experienced with metrics is gonna go, well, obviously we don't do it that way, right? Nobody would capture all 63 status codes. We bucket it. We capture the 1xx, 2xx, 3xx, 4xx, 5xx, because it's all about reducing that cardinality, because you pay so much money for cardinality. And yes, that is what everyone does. But that's not great. It's really valuable. You need to know whether it was a 50x or 502 or a 504. 50x tells you very little. I don't know how many times I've debugged some incredibly difficult problem just because it had a weird status code or a weird string. Details matter. I would never claim that good observability is cheap. Not in any universe, 1.0, 2.0, 22,000.0. But I will say that as your bill goes up, the value you get out of it should not go down. The value should go up too. And I just talked about that. But that's just money costs. And it's easy to say just money, because when you don't have any, it's the most important thing in the world. But I feel like the more important thing is like the dark matter of lost engineering cycles. Oh, shit, I had a whole, there, now you can see my math. 63,000 a month for request out latency. Blew my mind. The cost model, yeah, as costs go up, the value you get out goes down. Observability 2.0 isn't cheap, but its costs are predictable, and the value you get is aligned with your engineering value. And so here's something that a lot of people, I hear this so much. I hear people say, that sounds really great, but we're not ready for Observability 2.0. We're still struggling with 1.0. Which is how often do you hear someone say, gosh, we're not ready for MySQL 6.0. We're still struggling for 4.1. We're still struggling with Windows 3.11. I mean, it doesn't really make any sense. And the fact is, Observability 2.0 is so much easier. It's faster, it's cheaper, it's simpler, it's easier. Because the way that we're doing things now is the hard way. It is so hard. It's so hard that it's become not obvious to us how hard it is, because we're used to it. We have learned to be so clever when it comes to trying to wring utility out of metrics and logs. What if we didn't have to work that hard? What if it was just all data? What if you could just, anytime you saw something that you were like, this might be useful someday, just toss it in the blob. Forget about it. What kind of cardinality it is, I don't care. Doesn't matter. Doesn't matter. Just toss it in the blob and forget about it. Because not only is high cardinality supported into Observability 2.0, toss in all the strings, all the IDs, everything you want, but the width of the event doesn't matter. Now, data is made valuable by context. And one of the problems with time series databases is they don't store any contextual data at all. They store no relationships between this metric and that metric. The only relationship there is a tag, which just means you're storing it 2 times, or as many times as you have. But if what makes data valuable is context, then width is context, right? If you have a log event that has 10 key value pairs, that's more valuable than a log event with 2 key value pairs. But a log event with 500 key value pairs is insanely powerful. A log event with 1,000 key value pairs, 1,000 different nouns describing every request that goes through your system. That's language internals, database queries, external requests, latencies, IDs, anything you can think of that might describe this request. You know how powerful that is as an engineer if you can just look at the data. Everybody's reaching for AI for their observability tools, and my somewhat cynical take on this is that they're reaching for AI because they don't have the data. So they're like, well, we didn't store the connective tissue that would allow us to calculate or compute what an outlier is, so let's just guess and call it AI. Structured logs are the bridge to our future, and metrics are the bridge to our past. With structured logs, you should be able to capture all of these dimensions that went into our $63,000 a month heat map and just slice and dice, break down, group by, zoom in, zoom out. You build better systems this way, and you become a better engineer by building this way. Instead of guessing, you form hypotheses, you take small steps. So what you can do now, and I'm a vendor, so you're probably expecting me to say, buy Honeycomb, but that's not what I'm here for. And there are lots of things that every single one of us, even if you run for one of those cheapskate companies that's like, we are going to compile our own Ganglia binaries from scratch because that's what we feel like spending our engineer salaries on. That's fine. There's stuff that you can do. Instrument your code using the principles of canonical logs. If you're not familiar with the term, look it up. It's brilliant. This guy at Stripe coined the term. He goes into a lot of detail. And basically it just means instead of emitting logs willy-nilly throughout the request, you emit one log event per request per service, and you make it wide. All the things you would have just like spat out here and there, you wait until you gather them all up, and then you emit them in one wide request. It is so powerful. It will transform your ability to debug your systems. Add trace IDs and span IDs. There shouldn't have to be a different tool for tracing than logging, because span should just be, you should just be able to visualize them over time as a trace, right? So you can get a long way towards that by just adding some IDs. Feed your data into a columnar store. These are in order of importance, so start at the top, and however far you get down or don't, it doesn't really matter because every step you take will make your lives materially better. Taking all of that energy and money that we are sinking into metrics-backed tools is insanity. Take it and start bit by bit applying that money and time and energy to structured log-based tools. If you take anything away from this talk, I hope it's that. Metrics are the bridge to our past. Structured logs are the bridge to our future. What got us here won't get us there. We used to be able to form these incredibly sophisticated, detailed mental maps of our systems and just, reason about them, which makes about as much sense as trying to debug your code by reading it. It doesn't work. Our systems are changing underneath us every day, and that's as it should be, right? We have to develop these muscles of instrumenting for observability, or we're screwed. I remember when I came to Silicon Valley when I was 19 years old, and the whole sleep under your desk trope was in full effect. And there were a lot of things you could kind of brute force at that point in time. But increasingly, anything you can brute force, anything you can work through the night, night after night to build, is getting automated out of existence. What isn't getting automated out of existence? It's the creative part. It's the hard parts. It's the interesting parts about building systems that work, that are sustainable, that can be, passed on from engineer to engineer and understood. Writing code is not the hard part. It never has been. The hard part, I'm not trying to say writing code is trivial. It's not, as everyone who's ever tried learning it knows. But writing good code is very hard. And writing good code means taking the entire software lifecycle into effect, understanding it, maintaining it, scaling it. We can't try to hold all of this in our heads anymore and reason about it. And those who try will lose. Our systems are too unpredictable and emergent. Runbooks and canned playbooks don't work for the most part. What does work? Giving people the time and space to be creative, to be well rested, to not spend all their time and toil just down, building all of the stuff that, firefighting and dependency storms. And it's really important that we dig ourselves out of that hole. And that's why I'm excited about observability. I think that 2.0 really advances the craft of software engineering. I think we're trying, big picture, what we're trying to do is make it faster and safer to bring change into the world. We're trying to make this a more humane profession, and we're trying to make this a more powerful and sustainable skill set. And whenever people ask me, what is the main thing that holds us back from this? I'm like, It's that people don't believe it's possible. And I get why. We're all very jaded at this point. We're all used to people coming and telling us things can be so much better. But what I've experienced is that we have a hard time getting people to believe us about how much better it can be. We should demand more from our tools. We should demand more from our vendors. Everyone deserves good tools. So in the end, I'm going to close with my very favorite picture of all time, which is, are we too busy to improve? Thank you.